So you sort of have to put it in perspective. A dB down at 16 kilohertz, it's perfectly good for my world. At my age, I'm lucky to hear anything above 16 kilohertz. So a dB down, yeah, this tape machine's doing better than I am, no doubt. So yeah, whatever headwear is going on here, just gonna roll with it. Oh man, am I ever excited for today's session. Totally inspired by an awesome comment and question left by Pete55 on a recent session I posted called Balanced Audio, where I was talking about the ongoing restoration of my old Revox A77. Well, check out what Pete55 shares. What are you intending to use the A77 for? Effects? Masters? Do you have an MRL tape for that machine? Or is it even possible to do a proper electronic and or physical alignment on that deck? Oh yeah, Pete55, that's an awesome question, my friend. And honestly, when I went into this restoration project, my main goal was to just restore my old tape echo machine. This particular Revox A77 came out of the world famous Mushroom Studios. And the original owner did a modification of this machine, adding a vari-speed to it. And not just any vari-speed. This vari-speed gives me approximately 100% control. So, I can slow this tape deck down to a crawl, which makes it an incredibly cool sounding tape echo, and particularly glitch-free because there's no tape loop running on it. And so for today's session, I want to walk through my basic alignment procedure for the A77. And this is a procedure that, as an assistant back in the day, you had to become an expert at. It wasn't unusual for an assistant engineer to come into the studio early and have to align every single tape machine in the whole room before the band even showed up. When working in analog, different clients would show up with different tape formulations and different operating levels. So every time that happened and there was a change, every machine in the room had to be calibrated to match that operating level and that tape formulation. So let's get into it. Before we get started, it's very important for me to distinguish something. What I'm referring to today is what I would call a real world alignment. If I wanted to align this tape machine and bring it back to factory specs, yeah, I'd need a technician and a lot more equipment. Things like a digital frequency counter, a distortion factor meter, a wow and flutter meter, all kinds of equipment that I don't actually have. So the alignment that I'm talking about doing today is the one that I was taught back in the studio, one that I would consider your everyday working alignment. So how are we going to proceed on this alignment? Well, we're going to follow a pretty old school concept. We're going to read the manual. And it just so happens that I have the original service manual for the A77. So boom, page 26. Here we go. Now the first thing they talk about is demagnetizing the tape machine. Now there's all kinds of theories and ideas out on the internet about what demagnetizing is all about. And for the most part, it's thought of as some kind of voodoo or something. A lot of people don't even believe it exists. But I can promise you that a tape machine like a Revox A77, it can become magnetized over time. And the process of demagnetizing is to do just that. Over a long period of time of playing magnetic tape across those heads and all those metal parts, some of that magnetism transfers to the metal parts and over time starts to build up. Well, it can get so severe that you can actually damage test tapes and stuff. Demagnetizing. Magnetic heads and tape guides are to be demagnetized before any measurement or adjustment with running tape. First thing we're going to do, turn the power off to the Revox. This is very important. Before you even consider doing a demag job, you got to shut the power down to this thing. Well, another important precaution to take before we turn on this demagnetizer and get busy here is to make sure that I've cleared the area of any really sensitive materials like hard drives, credit card, anything that you think might be affected by that magnetic field, because there's no question that this demagnetizer, it's strong. When you plug that thing in and you start bringing it into a piece of metal, you can feel the flux, you can feel the magnetic field, and it's really quite something. Okay, so I've cleared my desk of sensitive materials, all my hard drives and everything are a safe distance, and I've got the power off on the A77. So grab our handy mag demagnetizer and let's get busy. Okay, so the idea with this demagnetizer, and you can see that it's not powered yet, very important. When you apply power to this demagnetizer, you don't want it close to the machine. You want this thing to be at least a couple of feet away from the area that you plan on demagnetizing. You know, there's a whole lot of theories as to whether or not people should be using these devices. Yeah, I promise you, when Revox suggests that I demagnetize my tape machine, I just follow their instructions. There's way less voodoo involved in this than people think. This is a real world device that actually physically demagnetizes a tape machine. How it does that is a scientific session all by itself. Yeah, I believe Revox knew what they were doing. There's a reason that they put demagnetizing first and foremost in the alignment procedure. So let's demagnetize this tape machine. I'm a good 2 feet away from the machine so I can safely turn on my demagnetizer. Boom, I can feel it and I can hear it running. Okay, I'm gonna come in and start on the leftmost side with that tension arm. And what I'm doing is I'm just bringing that probe nice and close to the tension arm. Not actually touching it, though I don't think you can actually hurt anything by doing so. I just like to bring that probe nice and close to all these metal parts. Kind of saturate them for a second before very carefully and slowly moving along to the next part of the tape path. So the same thing, I'm just going to move that probe slowly back and forth over all the metal parts. As I come to the record head, I'm going to feel it much stronger now. I can feel a huge pull with this demagnetizer, and I can actually hear it. There's a sort of hum. So pass over that record head a couple times. Very carefully move over to the playback head. Same thing, just demagnetize that head by carefully and slowly passing the probe back and forth over the head. Move my way over to the guide, the fixed guide, and of course the capstan. Now I'm demagnetizing the capstan. And I can feel the pull on it. Carefully move my way over to this roller guide, the last roller on the right. Pass around that a couple times. And then very carefully and slowly, I'm going to take this demagnetizer and I'm going to move away from the tape machine. Just like so. I'm going to bring it all the way back out until I'm a good 2 feet away from the machine, when I can safely turn it off. Okay, so we followed the instructions and demagnetized the tape machine. I can turn the power back on and move on to the next step. Playback adjustment. Check of balance adjustment. This is sort of unique to an A77. This machine was sort of designed for the consumer market, not really for the professional studio market. So believe it or not, there's a balance control on the output of this thing. So before we can do anything, the first thing we have to do is establish that that balance control is in the middle. In other words, that the signals that we send into this machine are equally coming out the left and right channel. So to check this balance adjustment, I simply send 1 kilohertz out of my console into the Revox, switch it to input, and then monitor the output of the Revox on my main meter bridge, which allows me to then just adjust this balance so that I get the same level coming out of both sides. It's not so important exactly what that level is right now. We just want to make sure that they're equal. So let's get that done. I'm going to go over to my console. I'm going to turn up 1 kilohertz. Well, what's important about this balance control is once it's set and it's accurately outputting evenly on both sides, we absolutely don't want to touch it for the rest of the calibration. All right, well, the next procedure is the azimuth adjustment of the playback head. So at this stage, I can remove my NAB hub adapters. And Pete 55, yeah, you bet I've got an MRL tape. Brand new, I just ordered this thing and they're expensive. So you want to make sure that your record ready buttons are out and in the safe position, right? Don't want to be recording over this thing. This is such an important aspect of doing a calibration. When you're talking about an analog tape machine like this is the key. Why? Because this tape was made in a laboratory with a very specific operating level. Let's load this thing up, give it a try. As always, any kind of important master tape, including a test tape like this, is tail out. So I have to put it on the take-up reel and actually rewind that tape in order to use it. Load 7.5-inch test tape and advance to azimuth adjustment portion, 10 kilohertz. I'm there now. I'm going to reset my counter right now. All right, following the instructions in the manual, the first coarse azimuth adjustment I make by switching the output of the tape machine so that I'm reading just channel 1 on the meters, okay? So there's a switch that allows me to do that on the A77. In fact, I can switch from stereo, channel 1, channel 2, or mono. So for the first coarse azimuth adjustment, both meters are reading channel 1 off the machine. Next procedure, it says switch to play and set output voltage to a maximum with screw C. I'm going to take a plastic screwdriver, switch play, and I'm going to adjust for maximum. Okay, that's maximum. Now that we've got the coarse azimuth, we can move on to the phase method, which requires me to switch the playback to mono so that both channels now are summed and fed to the meters. It's very important that you do the first step first, because with azimuth, if you jump to the fine setting first, there's a risk that you can be a full 90 degrees out of phase. So it's very critical to do the coarse azimuth adjustment first. I'm going to do the same thing, play the 10 kilohertz section, and I'm going to readjust that screw C for maximum output. I would say that's it. And here it is right here. It's absolutely essential to accomplish the coarse adjustment per 631 before using this method to avoid phase errors larger than 90 degrees, okay? So we're covered. I know we're good. And then very important, once we get that fine azimuth adjustment on the playback head, we want to use a little drop of lacquer on that screw to set it, to make sure that it doesn't move from this point. So what I'm going to do is go ahead and do just that. We're going to put a drop of lacquer right on this thing. Boom. Done. Yeah, this step of adding a drop of lacquer is very important, because I just know that until I actually move that screw again with a driver, it's not going to move for any reason. If I bump the machine or, set it down a little bit too aggressively, I know that that head and that azimuth adjustment is not going to move. It's sort of glued in place, so to speak. So next phase, playback level from test tape. So we're going to advance test tape to level portion, which is going to be further back here.
MRL calibration tape, NAB equalization at 250 nanowebers per meter, fringing compensated, 1 kilohertz.
And then adjust repro level. So here we go. And then channel 2. That was just a hair too much and I went down, so it's just like a tiny tweak. You almost want to just breathe on it. Okay, so I've set the repro level of both channels, left and right. That's pretty impressive. I'm playing back 16 kilohertz off this test tape, and I'm only a dB and a half down on my meter bridge. That's pretty spectacular for an analog tape machine running at 7.5 IPS that has some head wear. This is so important. I made a decision when I went to restore this machine that I did not want to relap the heads or find a new set of heads. I loved the sound of this tape machine for decades as a tape echo. And in my experience, changing the tape heads, oh man, that could have devastating effects on the sound that I fell so much in love with. So I made a decision that I'm going to keep the old worn heads exactly as they are. And it's fairly impressive. I mean, when I play 10 kilohertz off this tape, it's about 3/4 of a dB down. When I play 16 kilohertz, it's only a dB and a half. So you sort of have to put it in perspective. A dB and a half down at 16 kilohertz, it's perfectly good for my world. At my age, I'm lucky to hear anything above 16 kilohertz. So a dB and a half down, Yeah, this tape machine's doing better than I am, no doubt. So yeah, whatever headwear is going on here, just gonna roll with it. Okay, so I've loaded up some fresh tape that we can record on, and I've got the machine and record ready. The next adjustment we're gonna make is setting the record bias trap. There's a couple of different methods that you can go about to setting bias. My preferred method is using my ear with a low frequency, only because that's how I was taught to do it as an assistant engineer. And I absolutely know from experience that you get great results using your own ear to set bias. So no question, I'm gonna deviate from Revox's suggested practice by using a low frequency and using my ear to set bias. So I do that by setting 30 hertz on my oscillator. Let me go do that. It's a very simple procedure that involves putting the machine into record, recording 30 hertz, listening back to it in a pair of headphones, and while you're doing that, finding the clean point, I call it. Well, this is where you take the bias control and you lower that bias control until you start to introduce noise to that low frequency. You sort of get an idea of where that is, and then you go the opposite way. You start to then increase the bias until that sound cleans right up and goes the opposite way. It starts to get noisy again on the top end. The idea is that you find the null, you find that cleanest point that you can. All right, I got the bias set. Next up, azimuth adjustment for the record head, coarse. Set AF generator to 10K, load tape, switch record. Adjust for maximum signal with screw B. Turn slowly, because there's of course a delay to the repro head, right? Now, in my own experience, each one of these machines usually has its own set of instructions to get through that alignment. If you're talking about a Studer professional machine, multi-track, typically on each one of those amplifiers, there's more adjustment. You actually have fine-tune adjustment for high and low frequency playback. Something like this Revox is much more complicated in the fact that the high frequency playback is directly related to the RF bias. All right, now I've adjusted the RF bias on the oscillator card. Now I'm gonna do the fine record head azimuth adjustment. What they're suggesting is that I go to mono. Okay, so screw B on the record head. Here we go for maximum. Ooh. There it is. What they're suggesting is now that I pass through some lower frequencies, just double check it on the meter. Okay, looking good. As I swept the tone generator down, output stayed at 0 across all the frequencies, so we're all set there. Okay, record level. Input, I'm sending 0 off my desk. Output, okay, input and output reads the same. Well, that covers what I consider a basic and real world calibration, where we're just really focused on levels, frequency response, and making sure that the azimuth is set correctly on both the playback and record head. Well, now that we've got this thing calibrated, let's set up the camera on the meter bridge and let's have a look at the frequency response of this A77. 10 kilohertz. 16 kilohertz. 18 kilohertz. 20 kilohertz. 500 hertz. 75 hertz. 20 hertz. 40 hertz. and I'm just going to start sweeping. Now, something interesting to point out. Earlier on in the calibration, when I was playing back the 16 kilohertz test tone off the MRL tape, my playback head was down about 1.5 dB. Notice that I'm able to actually reproduce 0 at 16 kilohertz in record. And this is something that's sort of the benefit of having all these adjustments, right? When I carefully adjust the RF bias and the record EQ and all of these different settings, I can actually compensate for that head wear on the playback head by sort of over modulating some of those frequencies. And that's exactly what I've done here. We're looking at 16 kilohertz now playing off the tape. Even if I go all the way up to 18.5, let's say, 18.5, that's pretty impressive for a 45-year-old tape machine that has the original head stack on it. It's only down about 1.5 dB at 18 kilohertz. So essentially, I'm sort of doing a custom alignment and calibration to make up for the limitations of my particular Revox. And I get away with it because I'm not sharing my tapes with anybody. I'm strictly using this tape machine in my own studio. So I can set this calibration up however I like. And this is exactly how I do it. I sort of overcompensate on the record side to make up for the loss of high frequency on the playback head. And the results that I get, oh yeah, I'm going to share that next week. They're spectacular. You would not believe how good this Revox A77 sounds. Well, thank you very much for sitting in on today's session. And please stay tuned next week. Because Pete, oh yeah, we're going to find out exactly how I like to use this Revox.